Water is essential for human life. Shocking, I know, but it's why human civilizations historically sprouted up along the banks of rivers, lakes, and oceans. Water is the main substance in our bodies, making up more than 50% of a person's body weight, and it's directly involved in every biochemical reaction in each cell in our body. Ultimately, maintaining the right balance of water is what keeps us alive. Water is a V shaped molecule made up of two hydrogen atoms that bind to a single oxygen atom, and it's commonly referred to by its chemical composition of H2O. The bond between hydrogen and oxygen is a way of representing the fact that the two atoms share a single electron that zips around in the space between them. The space where it moves around is called an electron cloud, and it's a bit lopsided since the sharing isn't completely balanced. That's because the oxygen is more electronegative, which means it pulls the electron closer. Because the electron spends a bit more time on the side nearest the oxygen has a partial negative charge, and the hydrogens have a partial positive charge. That's called a dipole, with the hydrogen end of the bond having a slight positive charge and the oxygen end having a slight negative charge. In fact, it's this dipole that really explains the magic of water, because it allows the slightly positive hydrogens to line up with slightly negative oxygen atoms from other water molecules. That attraction between water molecules is called a hydrogen bond, and ultimately, it's the reason that water molecules huddle up together. Think about the dew droplets that form on leaves early in the morning. That bead is huddled up because of millions of hydrogen bonds within it. Also, having lots of slightly positive hydrogens and slightly negative oxygens is what allows water to be a great solvent for other molecules like sugar and salt, which can easily dissolve into it. Total body water can be subdivided into two major compartments: intracellular fluid, which is fluid inside cells, and extracellular fluid, which is fluid outside of cells, like in the blood and in the interstitial tissues between cells. Let's say that a person's total water makes up 60% of their body weight. Two-thirds of that 60%, or 40% of body weight, is intracellular fluid, and the other third, or 20% of body weight, is extracellular. Both inside and outside the cells, water acts as a solvent for electrically charged molecules called ions, or electrolytes. When water dissolves electrolytes, the slightly negatively charged oxygen attracts positive ions like sodium, and the slightly positively charged hydrogen attracts negative ions like chloride. That's how table salt, or NaCl, dissolves into water. In our bodies, the main positive electrolytes are sodium, potassium, calcium, and magnesium, and the main negative electrolytes are chlorine, bicarbonate, phosphate, and sulfate. These are kept at very specific concentrations both within and outside of the cell, through a variety of processes. One mechanism is osmosis, where water moves from the more dilute compartment, or one with low concentration, to the more concentrated compartment. So, blood osmolarity, which is the overall concentration of all substances dissolved in the blood, like electrolytes, glucose, and urea, is a good measure of hydration status, and it's normally around 300 milliosmoles per liter. When blood osmolarity is high, a common reason is that there's not enough water in the body, like in dehydration. When blood osmolarity is low, a common reason is that there's too much water, like when it's being retained by the kidneys. Normally, the amount of total body water is balanced through ingestion and elimination of water, ins and outs. About 80% of our water intake comes from drinking fluids, the other 20% comes from food. Water content in food varies, but some fruits and vegetables, like watermelon or strawberries, are 90% water by weight. As far as water output goes, we eliminate water through breathing, as humidified air leaves the body, as well as through sweating, urinating, and with bowel movements. In addition to the water we get from foods, the recommended daily amount of fluid intake for women is around 9 glasses of water, or 2.2 liters, and for men, it's about 13 glasses, or 3 liters. But as we'll soon see, the amount of water needed per day can vary depending on many different factors. Plain water is the ideal choice when it comes to hydration, but all fluids, including caffeinated drinks like coffee and tea or flavored waters and juices, contribute to water intake. After we drink water, it travels all the way through our digestive tract until it reaches the small and large intestines, where water is absorbed into the bloodstream. When we're at rest, each heartbeat propels around 25% of our blood to the kidneys, where millions of nephrons filter it to produce urine. When we're properly hydrated, the kidneys produce between 800 and 2,000 milliliters of urine every day, and the urine has a pale yellow shade, like lemonade. I hope you're not drinking any right now. But some water, around 200 milliliters per day, is also lost during bowel movements. Sweat glands in the skin produce small amounts of sweat, and their production increases when we're nervous, when it's hot outside, or during exercise. The amount of sweat we lose each day varies quite a lot based on the level of activity in the person. So let's say on average it's 500 to 700 milliliters per day, even though some athletes can sweat more than a liter in an hour when it's really hot. Finally, there's the insensible water losses. They're called insensible because we're not aware of them. When we breathe in, water inside our body is able to humidify the air, and that water vapor is then lost when we breathe out. Water also constantly diffuses through the layers of our skin, keeping them elastic and nourished, but also evaporating at the skin's surface. This is in addition to losing water through our sweat glands. All in all, insensible losses account for an incredible 600 to 900 milliliters per day, which is a lot of water to lose without even really sensing it. I don't want to shock you again, but staying hydrated is important because water does so many important things in the body. Water makes up tears, mucus, saliva, and other secretions that protect or lubricate passageways in and out of the body, like the eyes, nose, mouth, and genitals. Lubrication is also important in the pleural and pericardial cavities in the chest, and the peritoneal cavity in the abdomen, where internal organs touch and slide over one another. It's also needed at the joints, where it helps form synovial fluid that keeps our bones from rubbing against one another. And water is critical for digestion. The water in saliva moistens food when we chew, while gastric and intestinal juices are a fluid environment in which digestive enzymes break down our meals. Water forms the bulk of blood, which allows oxygen and glucose to move around the body, and plays a role in eliminating toxins from the body through urination. Water also helps regulate body temperature. When we're hot, like during a vigorous workout, the capillaries in our skin dilate and sweat glands produce more sweat to dissipate heat. On the other hand, when we're cold, our blood vessels constrict, retaining heat. Water can also help with weight loss and maintaining a healthy body weight. Replacing sweetened drinks with water reduces calorie intake, and drinking water before and during a meal can increase our sense of fullness and prevent overeating. Now,